Since their introduction, tanks have been versatile, multi-purpose weapons capable of handling a wide spectrum of tasks on the battlefield. This versatility is largely due to the ammunition fired by tank cannons, ingeniously adapted for a variety of purposes. Some rounds are deadly and highly effective, while others are unusual or even bizarre. Today we'll share some fascinating and surprising facts about these unique rounds. So, let's begin. For different needs on the battlefield, tank shells are generally divided into three main groups: those for combating other tanks, those for destroying fortifications, and those for battling infantry. There are also shells that can be used for multiple functions, but we will get to that as well. Let's start first with shells designed to combat enemy tanks. Tank rounds designed for this purpose are primarily focused on penetrating thick armor, but there are many ways to disable or destroy the vehicle. These rounds can be divided into different types based on how they operate, each with a unique mechanism. The first group, which proved highly effective, is kinetic energy penetrators. Kinetic energy penetrators are designed to pierce armor using sheer force. These rounds rely on high velocity and a dense, hardened core to punch through enemy armor. They usually don't explode. Instead, they focus all their energy on a small point of impact, maximizing penetration. Having a high-speed penetrator ricocheting inside your tank is just enough without the need for any additional explosives. Initially, during the Second World War, simple armor-piercing rounds appeared in the form of solid steel shots, but they set the ground for developing modern kinetic energy penetrators, such as armor-piercing composite rigid, which had a dense tungsten core surrounded by a lighter outer shell. Then came the armor-piercing discarding sabot, which is a sub-caliber penetrator encased in a sabot that falls away after firing. This allowed a larger caliber gun to fire a dart of significantly smaller caliber, maintaining muzzle velocity but reducing air resistance. Precisely because of the extremely small contact area with armor, these darts can penetrate much thicker armor than ever before. This principle led to the improved and most advanced armor-piercing, fin-stabilized discarding sabot rounds, which can cleanly penetrate any existing tank's armor. One of the most lethal and famous rounds is the M829 armor-piercing, fin-stabilized discarding sabot round, developed by the United States. It combines advanced kinetic energy penetrator technology with depleted uranium, making it exceptionally effective against the heaviest armor. The penetrator is shaped into a slender, aerodynamic profile to maximize its penetration power and speed. The elongated projectile reduces air resistance and has extremely high muzzle velocities, often exceeding 1,500 meters per second. This high velocity, combined with the dense, streamlined penetrator, enables it to defeat modern composite armors and reactive armor systems. It can penetrate over 500 millimeters of rolled homogeneous armor at distances up to 2,000 meters, meaning it can go through the main armor of almost any contemporary tank. Unlike kinetic energy rounds, chemical energy penetrators use explosive energy to breach armor. These rounds use a chemical reaction to generate a high-temperature, high-pressure blast aimed at melting or burning through armor. The most well-known rounds of this type are high-explosive anti-tank, so-called heat. They use a shaped charge that focuses the explosive energy onto a small point of the target armor. The core of the charge is a cone lined with metal such as copper, which turns into a superheated jet of metal that can penetrate armor by melting and vaporizing it. These rounds do not depend on the velocity of the projectile, meaning that they can be effective at a wide range of speeds and are used in various platforms, including rocket-propelled grenades as well as tank shells. Typically, heat rounds can penetrate armor thickness of up to several times the diameter of the charge. For instance, a 120mm heat round can potentially penetrate around 400 to 600 millimeters of rolled homogeneous armor. High-explosive squash head rounds, for example, work differently. They release a high-explosive charge that squashes against the armor surface and detonates. The explosion causes a shockwave to travel through the armor, creating spalling on the inside of the vehicle which disperses fragments that can injure the crew and damage equipment. The L-31 high-explosive squash head is a British 120mm tank shell used primarily by the Challenger 2 tank, which operates on this principle, and it could also be used effectively for destroying bunkers and other targets besides enemy armor. To protect themselves, most modern tanks use layers of different materials to absorb and dissipate the energy of kinetic penetrators, but also to prevent shockwaves from high-explosive squash head rounds to cause spalling inside the tank and kill its crew by pieces of armor flying at great speeds, becoming bullets, essentially. These were the main and most frequently used rounds to combat enemy armor. Let's now explain some made for enemy infantry. The first and perhaps most terrifying rounds designed for close combat against enemy infantry are definitely canister rounds. They literally turn the tank gun into a huge shotgun that can fire a large number of small steel balls or flechettes that spread out over a wide area. This round is specifically effective in clearing out exposed infantry over open terrain or in light cover. A typical 120mm canister round might contain up to 2,000 tungsten balls, each about 10mm in diameter. Upon firing, these balls disperse over a cone approximately 60 degrees wide, covering a football field-sized area at a range of 300 to 500 meters. Then there are also multi-purpose anti-tank rounds. They are equipped with a programmable fuse that can be set to detonate on impact or in the air, making them suitable for a variety of targets, including light armored vehicles, low-flying aircraft, and personnel. These rounds generally contain a high explosive charge that can be detonated above the ground to create an airburst effect, dispersing lethal fragments over a wide radius. The M830A1 multi-purpose anti-tank round, for example, can switch between anti-armor and airburst modes, which provides tank crews with a versatile weapon without needing to carry and load many different shell types. Of course, the basic type of tank shells are definitely high explosive, which can cause significant damage to all targets. Modern tanks fire HE shells that contain about 10 to 15 pounds of high explosive and can be lethal in a radius of 50 meters. Now, let's explain one truly terrifying tank round. The M64 white phosphorus round was used by Sherman tanks in World War II, and beyond its basic role as a smokescreen and artillery spotting, tank crews soon discovered that it could be useful in other roles as well. White phosphorus, after igniting and being exposed to air, burns at a temperature of 5,000 degrees Fahrenheit, and every piece of phosphorus spread by the explosion that lands on human skin or clothing has a catastrophic effect. It burns until completely depleted of oxygen. It could penetrate fortifications and start fires, but the most terrifying impact would be when falling on soldiers. Let's just say, without graphic descriptions, that it could burn through bones. Besides, it also produces toxic gases that can suffocate enemies in fortifications as well as in tanks. There are several examples from World War II where significantly more powerful German tanks were destroyed or captured using these rounds. Apart from being able to ignite the exterior of the tank, or fragments of burning phosphorus falling on the crew through open hatches, the first goal was to blind the enemy with smoke, which was always successful. However, white phosphorus smoke is extremely toxic, and in several situations the crew of German tanks had to bail out just to avoid suffocation. German tanks were designed to draw air through the crew compartment, using that as a sort of filter and pulling fresh air in for the crew. When this is combined with smoke and particles of white phosphorus, a terrible combination is formed where the crew can suffocate or must immediately leave their tank. In this way, and Sherman Company, ambushed by King Tigers, managed to destroy 3 King Tigers, 2 of them in completely working condition, precisely because of the WP rounds they used to hit German tanks, knowing that their AP rounds stood no chance. Now, let's talk about one projectile fired from a tank that is outright weird and bizarre. However, when it hits the target, the destruction is not something to be laughed upon. The Sturmtiger was one of Germany's World War II bizarre weapon systems, built on the chassis of the Tiger I tank and equipped with a massive 380mm enormous rocket mortar. The ammunition used by the Sturmtiger was the 380mm Raketenwerfer 61, a rocket-assisted projectile. This design allowed it to carry a far larger explosive payload than a standard artillery round of the same caliber could have. The rocket motor behind the shell helped it achieve sufficient velocity to stabilize its flight after leaving the barrel, making it somewhat more accurate over its relatively short effective range. The complete round was approximately 1.5 meters long and weighed 760 pounds, with the explosive charge alone weighing 275 pounds. Although the effective range was quite short, the round could demolish fortified structures with ease. The 380mm round was intended to obliterate strongpoints, blasting through concrete and steel to collapse entire buildings or clear fortified positions with a single hit. However, in practice, they were not effective and were made late in the war, with only 18 ever built. The Sturmtiger could carry only 14 rounds at a time and was equipped with a built-in crane to lift the rounds into the breech. It typically required the efforts of the entire vehicle crew to manage the loading process and could fire just a couple of rounds per hour, which was an extremely low firing rate. Nevertheless, although it failed, it still is a really interesting weapon